In this video, we're going to use regression analysis to evaluate the power of 7 different team batting statistics to predict the number of runs that a particular team scores in a particular year. So let's start by opening up a big data file. You can find this data file on our Moodle page. It's just called Team Hitting Data. And I've loaded my data set, as we can see in this command here. Let's start by taking a look at the data as usual. So hit describe. And I see that I've got 32 variables and I've got 2,514 entries. Each of these corresponds to a particular team in a particular year. So I've got about 100 years worth of data in this data set. The particular variable we're going to be trying to predict is runs. So that's the variable there. And we're going to be looking at these batting statistics we can find down toward the bottom: batting average, on-base percentage, slugging, OPS, which is the sum of OBP and slugging, isolated power, total average, and runs created. So let's start by making a graph. And let's just start with the first of our 7 batting statistics, batting average. And let's go up to our graphics pull-down menu, and we're going to choose two-way graph and hit create. So our Y variable in every analysis we're going to do in this video is runs. So we're going to find runs and put that there. And we're going to try batting average first. So it's down near the bottom. So we have that there. But I don't really want to do the relationship between runs and batting average for all the years combined. I want to do it for a particular year because players change, the nature of the baseball changes, the pitching mound changes. So we want to restrict ourselves to a single year. So I'm just going to go up and click the if in command, and I can restrict the observations to a particular year. Now, Stata is case sensitive, so I'm going to use year, which you can find right over here, but I've got to make sure that I've capitalized every one of the letters. And let's just pick a year, let's say 1982, and it looks like that would be a proper command. I said year should be equal to 1982. Well, we're going to submit this, accept it, and submit it, but we're going to find that we have an error. It tells me that I have an invalid syntax. Well, the problem is a peculiarity of Stata, which is, if we go back to our graphics menu, I'm going to edit, go back to my if-then command. When you are setting a variable to a particular numeric value in a restriction, you have to put in a double equal sign. So year has to be equal to 1982, and we accept that, and we submit that, and our graph is created. So we have what appears to be a linear relationship between batting average and runs scored, that if you know the batting average, you can make a reasonable estimate of how many runs a team would score. Teams with higher batting averages score more runs than teams with low batting averages. Well, let's ask Stata to analyze our regression with a table. So we'll go back to our main menu here, and we'll just go up to Statistics, Linear Models and Related, and pick Linear Regression. And our dependent variable is going to be runs again. And our independent variable is going to be average. There it is. And again, I'm going to restrict myself to a particular year. So we'll use that same year. And I'll say OK. And I've got my regression analysis here. Remember, the two important variables or values we're going to be looking at are the probability, the p-value, and the r-square value. The p-value is very small, which means that there is, in fact, a strong relationship between the two variables. Remember, we want this number to be less than 0.05 to claim there's a relationship between the two, and this is clearly less than 0.05. The R-square value represents how much of the variation in runs scored can be explained by knowing just what the batting average is. Remember, this could be up to 100%, and this is relatively low, 0.58. So what this tells us is that 58% of the variation in runs can be predicted if we know what the batting average is, but that still leaves us about 42% of the variation unexplained. Let's go back to our graph, and what I'm going to do is to add the regression line through the points. So let's go back to my command window here and go up and grab that old command there, and I'm just going to add a new command here. Just easy to do with the command. We could do it through the graphics drop-down menu as well. It's just a little slower to do it that way. And there's the line. So this is the best fit line through this set of 26 points. And you can see that in a few cases the prediction is dead on, that the batting average for a team that bats about 245 should score about 610 runs, and that's exactly what they get. But there's some teams, like this team here, that outperform their batting average. They had a team batting average of about 230, but they scored far more runs than we would have predicted. And on the other hand, this team here, which had a team batting average of about 250, scored fewer runs than we would have predicted. So we do find batting average to be a useful predictor, but it's not a spectacular one. So let's go back to our analysis here, and let's take a look at the number of observations. We have 26. So that means there were 26 Major League Baseball teams playing in 1982. But 1982 was before we had interleague play. And that meant that National League players and American League players never played each other except in the World Series. So what we probably would want to do is to separate out the two leagues. We want to do a separate analysis for the National League and for the American League, because after all, we've got totally different pitchers and different hitters. So we can do that fairly easily as well. What I'm going to do is just to go back up to my statistics menu here and go back to linear regression, and we're back to our original value here. So I'm going to click on the by, if, and in, and I'm going to go up and click at this box here because I am going to ask Stata to separate out the 1982 data by league. So I just click on league like so, and click OK. And now you can see I have the American League when there were 14 teams, and the National League where there were 12 teams. In both cases, my p-value is small, far less than 0.05, both cases. So for both the American League and the National League, I do have a strong relationship between runs and batting average. The R-square for the American League is about 56%, and for the National League, slightly worse, but still reasonable, 54%. Let's take a look at this information graphically. So what I'm going to do is to simply make the graph. I'm going to ask Stata to do the graph by a command, and so I'm just going to modify this particular one here. So what I'm going to do is just to add this restriction here. And now I've broken up the major leagues into the American League and the National League, and I've got my 2 points, 2 sets of points for the American League and the National League, and the 2 regression lines, the one for the American League here and for the National League here. And you can see that the slopes of the lines are close but not exactly the same. It looks like this is a little flatter slope than this one here. But it's a very nice way of taking a look at the effect of run scored if you know what the batting average is. But in both cases, we've got some outliers, some of the variation we don't explain by batting average. This point is quite a bit off the line, this point is quite a bit off the line, so forth. So maybe we could find another batting statistic that would be a better predictor than batting average. Let's go back to our main screen here, and what I'm going to do is to take advantage of the fact that I have this review of commands right here, and I can pick the one that I want, and I'm going to go, because I want to separate out by league, I want to choose this particular command. So again, I could generate this by going up to the statistics menu and picking my dependent, independent variables, clicking on the by, expressing my year by 1982 with a double equal sign, clicking on this box and choosing league to split my data set into the two leagues. But I can do that very quickly by simply modifying my command line here. So you remember the next variable that we were going to look at was on base percentage. So let's just change that to here. Remember, I got to capitalize everything here because, to correspond to what the variable is. And let's take a look at that. Now I've redone my analysis. This time I am regressing runs against on base percentage. So what we see is that the probabilities are, again, far less than 0.05. So that tells me I should continue, that I've got a relationship between those two variables. And look at my R-square value. It's a little bit better than with batting average. So it's still not superb because I'm still not explaining 42% of the variation, but it seems to be a better predictor for that particular year. Let's try another one. Let's try OPS. And now we're getting somewhere. The probability's very low, but look at the R-square here. Almost 88% of the variation in runs I can explain if I know what the team OPS value is. And that's for the American League. For the National League, almost as good, 72%. So what I'm going to ask you to do in your statistics exercise is to prepare a table, and you're going to be reporting the R-square values, and you can just round those to two numbers, that's fine. So for the American League, for OBP, let's say we were going to use 1982, all you got to do is to go to your Word document, and I'm asking you to do 9 different years. So let's just put those in here. And I just figured out what my OBP was for those 2 years and leagues, and there's a start. So I can go back into Stata, grab my command, hit slugging, and my slugging value 0.85 and 0.66. And actually this was for OPS instead of OBP. And so anyway, I can go through and I add my slugging values. I go back to Stata, grab my command, look at runs created, get my values there. It looks like the runs created is even better in one case, not so great in a second. So that's what I want you to do for 9 different years. And to change the year, all you got to do is to say, well, let's take a look at what happened in 2011. And so in 2011, there were 14 American League teams and 16 National League teams, and the p-values are very small, and the R-squares are really pretty impressive for using runs created for those 2 years. I get those 2 values, 0.95, 0.91, take those back into my Word document, fill out my table, And in no time at all, you should be able to fill this table out, particularly if you work with a partner. And I have 3 questions at the end of the document for you to answer, and that's your exercise for this particular week. So what we will have accomplished in this exercise is the use of regression analysis to allow us to look at the relative strength of a number of independent variables in predicting a dependent variable. And in this case, the independent variables are different team hitting statistics, and the dependent variable we're trying to predict is the number of runs that a particular team scores.